we're going to make a proportion. So we're going to take these four numbers and make them into a proportion, into a fraction, and figure out what that missing number is. So when you cross multiply 25,000 times 80 million and then divide by the 5 million. So do that in your calculator if you have one. 25,000 times 80 million. I picked up my phone, not my calculator. 25,000 times.
How many zeros are with the million?
So because the millions here are both millions and millions, you don't need to put all the zeros. You can just put 8 and 80 and 5.
Okay.
So what number did you get? How many?
There's 6 zeros and 2 before.
Oh, there's a 2?
I got 400,000, but I don't know if I did that.
I got 4.
Oh, yeah, I had a 2.
There you go. So 400,000 trees is how many we would have to plant right now in order to clean as much air as we're saving in having windmills. So for the next one, we're going to do the exact same thing. We're just going to use the 660,000. So we're going to make that into our proportion. It's like the fraction x over 25,000 equals 660,000 over 5 million. So this time we're going to cross multiply this direction, 25,000 times 660,000, and divide by the 5 million. This time you are going to have your zeros. So million has 6 zeros in it.
What are we dividing by again? Like after we multiply?
So you're going to do 25,000 times 660,000 divided by 5 million. So 5 million has 6 zeros.
Okay.
That's why I get lost.
It's a lot of zeros, right?
Yeah.
So how many homes can we power right now? Absolutely. So you're going to put that into your table. And then I'm going to erase some of my arrows so that it looks a little cleaner. Because when we jump to the next part of the table, this gets confusing sometimes. Let me get another color too. So now we're going to make a proportion, 25,000 times 8.8 million. So that's going to be 8,800,000. That's 8.8 million. And then divide by the 5 million. And what do you get? How many watts are generated?
44,000.
44,000, absolutely. So for those who haven't kept up with us, this was 44,000, right? And homes powered was 3,300. And how many million trees was it?
400,000.
400,000.
But Miss B, why did you multiply the 25,000 by the 8.8 million?
Because if we're making a proportion, it would be x over 25,000, x over 25,000 equals 8.8 million over 5 million. These two things have to stay together, so they're in the numerator. And these two things have to stay together. They're in the denominator.
Oh, so it doesn't matter what numbers you use?
As long as they're a pair in the column, you can always do that. Mhm. Because they grow proportionally. Based on the watts generated, it's the same percentage of homes that are powered and the same percentage of tons of CO2 that we're saving and the same percentage of equivalent trees. So this is called direct variation, and you'll get that in Algebra 2 next year. Any questions on that? That seems like a lot of energy, right? That these windmills can produce. It's kind of crazy to think. So there is another link here. I don't know that it tells us anything different. They are going to build these 27 miles off the coast. And I think this does tell us when we're going to try to have a zero footprint. We're showing our commitment to a net zero emissions by leading the clean energy sector of offshore wind, fully constructed by 2026. Blah, blah, blah. 2 wind turbines are currently in operation. So they are going to create over 1,000 new jobs once this is fully built. What kind of jobs do you think are going to be created?
Probably some kind of engineer.
Probably some engineers for sure, right? And then it says down here, when fully constructed in 2026, we'll deliver up to, we plan to achieve net zero carbon dioxide and methane emissions across 16 states by 2050. So in the next 30 years, they want to have a net zero carbon dioxide emissions. That's kind of exciting. That will make our air so much cleaner.
I wonder how, like, other states, like the ones that are not touching, like, the ocean, wherever it's on the interstate, wherever, that kind of stuff.
So I know you've gone to, like, Indiana. You've gone to some of those middle of the country states, right?
Yeah.
There are, like, huge fields and plains out there in the middle of the country where they can put wind farms. There's also the Mississippi River where they can use hydroelectric power. Do that down some of the rivers there. And then the Rocky Mountains are even bigger than our Shenandoah Mountains out on the West Coast. And there's definitely some potential there for some either solar or wind because of ridge effects. So there's definitely ways to do it. It's just Virginia is trying to do it out in the ocean. North Carolina is trying to do it out in the ocean too, but they're getting blocked by a lot of environmental groups. Why do you think environmental groups might not want this to happen? Anybody have an idea? Let's look at this other site again. Some of it is because of habitat loss. See how small these ships look out here in the channel? So some of the argument is over shipping, like blocking the shipping lanes and stuff. I think that's kind of a crazy reason though, because look how much water there is. I mean, we've all seen the big barges that travel up the Atlantic and then into the Chesapeake Bay and into Norfolk. But look at how small those ships are compared to this ginormous windmill.
Right. So how would it be a problem?
The other thing that some people are objecting to, and this is a legitimate thing, you see the platform out there in the picture? Do I sound like a robot again?
Oh, in just a way.
It's been happening today. I'm sorry. I wish I knew how to fix that. But every once in a while, the picture of the platforms will come out, and they have to create pilings. They have to drive down the supports for these platforms. And that affects a lot of wildlife, like any whales, dolphins, anything that's in the water. They do not like the sound of making those pilings go down to support. So in the process of building these, there is a lot of disruption to wildlife. And that is definitely a consideration that needs to be had. Right? So let's move on to part 2. Well, I gave you a picture of 4 different sizes of windmills, so you could kind of get an idea of how big this ginormous thing is that they're planning on building. So we've got a little household windmill. Maybe you've got, like I have a cousin who lives out in Nebraska, and he's completely off the grid. He makes his own energy because he has like this home wind turbine, right? And that powers his entire house. Then there's some businesses and farms that have a slightly bigger one. And then if you ever drive down into North Carolina on 58, you'll see a whole bunch of wind farms out there. And that's this size. They're about 360 feet tall. The one that they're planning on building out off the ocean front is 660 feet tall. So that's like the baby and the Mac Daddy, right? And then a couple in between. I want to try to figure out how big the radius is, what the circumference in the area is, and then how big these little pieces in the in-betweens are. So we're going to do some calculating now. And down here, I'm going to give you an estimation. Use the image above to complete the table below. Estimate the diameter of each turbine as half of its height. This won't be perfect, but it will be a reasonable estimate. So how tall do you think this baby home turbine is? 70 feet? If this is 100 feet?
More like 125 maybe.
Oh, I thought it said 130.
Gotcha. All right. So if we say, do we say 125 or 130? What do we want to say? There's no right or wrong answer. We just need to pick one. I heard 125 first, so let's do that. So if it's 125 feet, and we said the diameter is half of the height, what's the diameter going to be?
75. Wait, I'm stupid.
Almost. If it was 150, it would be 75. Since it's 125, what's half of 125? 62 and a half. Your mental math is fantastic. And then the radius is half of the diameter, right? So if the radius is half of the diameter, that's 31.25. So down here in your table for radius for the small wind turbine, you're going to put 31.25. What about for the business farm? How tall is that one? This one here.
135, 140.
135, 140. If this was 125,
150.
maybe 150. Okay. And so what's the diameter?
75.
Nice. And then the radius?
42. 30. 30,
Wasn't it 30 something?
it's like 30, 36 and a half.
37 and a half. Nice. 37.5. So we're just filling out this table down here, right? What about the wind farms in Chesapeake?
They tall.
They are tall. What does it say on the chart?
360.
360. So what's the diameter?
180.
180, which means the radius is
90.
90.
I just won.
So I'll put 90 here. And then it's up off the chart, but how tall is the proposed one?
660.
660. So if we do 660 as the height, then what's the diameter and the radius?
330.
Yeah, and then 330 divided by 2 is 155.
Awesome. 165. So any ideas on how to answer this question? How many times more is the offshore than the home? So how many times bigger is this offshore than this home radius? Subtract? Is that how we get times?
Divide.
Divide, right?
Divide. So we're going to do 165 divided by 31.25. And what do we get?
5.28.
5.28. Okay. So at home, I want you guys to make sure you have all of that information.
Do we put percent or is it just like?
It's just a number because we did feet divided by feet. So it's just a number. Okay. And we could add in feet here. That always makes me happy. And then feet divided by feet is just a constant number. So how do we find circumference? What's the formula for circumference? 2 times pi times r. Absolutely. So now we've got to do some calculating. We've got to do 2 times pi times r. So as you do that math, 2 times pi times 31.25, put in the chat or unmute yourself and tell me what the answer is. What is 2 times pi times 31.25? It's definitely going to be in feet. So we're just doing
196.3.
I like it. What about the next one? Now we're still finding the circumference, but of this business size one, the one that could be on a farm. So 2 times pi times 37.5. And feel free to put your answer in the chat if you want, or you can just unmute yourself and call it out. Nice, Trayshawn. 235.5. Now we want to do the wind farm. Those are the ones you see down on 58 between here and Chesapeake, or between Chesapeake and North Carolina, Elizabeth City. Absolutely, Sterling.
If they don't got copy. If they don't got copy.
So 2 times 5 times 90. Should be about double the last one, which is interesting because 90 is a lot more than double the 37.
565.5.
Okay, yep. That'll work for me. Your decimals can be a little bit different here because some people use the button for pi and some people estimate it as 3.14. So your decimals and your rounding can definitely be a little bit off. Usually you guys are so talkative. The chat is like growing moss. Nobody's using it.
But Miss B, when she started talking, it's like nobody else wants to talk.
I know. I don't know why that is.
Depressing.
It is depressing.
Okay, this answer is 1,036.7.
Excellent.
Since nobody else wants to.
So how do I find how much bigger the circumference is of the offshore windmill versus the circumference of the home windmill? What math do I have to do?
Can't you just divide?
Yeah, absolutely. So 1036.7 divided by 196.3 is going to equal what?
Um, 5.28.
Yeah, could we round it to like 5.3? Would that be all right?
Yeah.
Okay. So the ratio of the radius and the ratio of the circumference are exactly the same. They're both a linear measurement. I would measure both of those with like a single line. They're both measured in feet, right? So let's calculate the area now. We're going to use the radius to calculate the area. Area equals pi times the radius squared. Remember that little caret means squared. So now let's do that. And I love hearing from Mariah. I love hearing from other people. So I'm glad Ethan chimed in. Trayshawn's working the chat. Let's see if we can get a couple of other people to join us with some calculations. You don't have to start with the first one. But you want to do pi r squared. And because we're squaring that radius, it's going to grow pretty fast.
All right, for the first one, I have got 3,067.
I got 3,067 point. That's what I got.
Awesome. We'll just leave it right there, 3,067. The radius was 30, the circumference was 200, and the area is 3,000. That's crazy. What about the next one?
And let's see what happened to the decimal at the end of it.
Oh, what is the decimal?
It's 0.96.
So can we round it to 3,068?
Yeah.
Excellent, Karma. 4,418. And that's feet squared. So the radius is only about 6 feet more, but it has almost 1,500 square feet more. It's crazy how fast area grows because we're squaring that radius, right? So what about the next one? That one grows even faster. We triple the radius from 30 to 90. And what happens to the area? It way more than triples. Dun, 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 dun. What's 3.14 times 90 squared?
25,447 squared.
47 is the end?
Well, there's a decimal, but I didn't round it yet.
Okay. I'm using 3.14 instead of the pi button. So you and I are getting slightly different answers, and that's cool.
Oh, I used the pi button.
Yeah, that's all right. I'm taking yours because it's bigger, because it's not rounded. So what about the Mac Daddy? Any projections? We've gone from 3,000 to 4,500 to 25,000. What's the next one going to go to? Elif answered questions early on. She doesn't want to say anything else. Ethan answered his one question. He's probably just trying to finish it and be done. He's so efficient. Ariana, you usually answer questions for me. You're usually very quick with a calculator. Ashley, you too.
I lost my calculator. Like, I've been looking for it for a while now, and I can't find it.
Oh, no.
I know Karma put the answer in the box, but it's at 85,529.
It is 85,000. Thank you. So just a reminder, what we've done is we've taken that radius that we calculated and we stuck it into our calculator. So 3.14 is pi times the radius squared. So that is definitely 85,500. And I'm going to write 30 because 29.8 is super close to 30. So stop and pause for a second. A 30-foot radius to a 90-foot radius, changed it from 3,000 square feet to 25,000 square feet. And less than doubling the 90-foot radius to 165-foot radius made it go from 25,000 square feet to 85,000 square feet. That's insane, right? This is how much area is covered by those blades as they spin. So now the question is, how many times bigger is the offshore than the home? So we're going to take this offshore number and divide it by the home number. So we're going to do 85530 divided by 3068. And what do we get? So all we're doing is taking this fourth column and dividing it by the first column. Anybody get a number?
27.87.
27.87. Can I do 27.9? Mm-hmm. What's 5.3 squared?
$28.09. Wait, Lindsay, I think that's supposed to be 27.
Is it 20? Oh, it is 27. You're right. So 27.9 is basically 5.3 squared. When we jumped to the area, we squared the radius. So because we squared it, this ratio is going to be squared. And that's kind of an interesting thing that happens when we start talking about two-dimensional shapes and then three-dimensional shapes. Okay. The last piece is kind of a throwback to what we talked about a few days ago, super briefly. So if I know the circumference and I want to know just the distance between the end of each blade, I'm talking about arc length. So the arc length here is going to be the total circumference, all of these numbers, divided by 3. So you're going to take 196.3 and divide by 3, and 235.5 and divide by 3, and 565.5 and divide by 3, and then tell me what those numbers are. We're taking that circumference and dividing it by 3 because we've got 3 sections in each windmill. It goes around, and it goes around again, and it goes around again. There's 3 arcs that make that circle because there's 3 blades. So again, you're going to do 196.3 divided by 3 and tell me what the answer is. Get 65 point something. I got 65.4. And that's going to be feet. So now I take 235.5 and divide it by 3 because there's 3 sections in each windmill. And what do we get there?
78.5.
Mm-hmm. And since we're talking about length, that's going to be feet. What about the next one?
Trayshawn put it in the chat.
I'm sorry. Trishan did say it in the chat. 188.5 feet. And then the last one. Should be about 300 maybe.
I have 345.56. So like, we round it up to 0.6.
Yeah, we can do that. So now let's predict before we do the math. What do we think is going to be here? If we've got feet and feet and feet, is it going to be the 5.3 ratio or the 27.9? 5.3. I agree. So let's do the math and verify that because it's always good to predict before you do the math. 65.4. That's going to equal what? 5.28. That's awesome. So the 5.28 or the 5.3, that's our linear ratio. Any measurement we take with that home windmill and the offshore windmill, as long as it's a linear measurement, is probably going to have a scale factor of 5.28. So that's really just a scale factor that we found. So we're going to do the same thing for sector area. If the whole area of the circle is the area that we calculated and it's cut into 3 pieces, this is, I call pizza math, right? If I've got 3 equal sections, I'm just going to take the total area and divide it by 3. So now we're taking this line and dividing that by 3 and putting it down here in these blanks. So the first one's going to be 1,000 something. My calculator was off. I hate it when I do that. Got basically 1,023 or 22.6, 22.7. Is that feet or feet squared? Feet squared, because I'm talking about area, right? So in the next column, we're going to do 4,418 divided by 3. And we get what?
I got 1,472.6.
Awesome. And is it 6 repeating?
Yeah.
2 more, ladies and gentlemen. 2 more. 25,000 divided by 3 is going to be 8 something. That's also going to be feet squared. And then last calculation, 85,000 square feet of area those blades pass through on that giant windmill that's going to power 600,000 homes. 8553 divided by 3. Should be almost 30,000.
I got 28,510.
Awesome. And then if we predict, what's the area going to be? What's the ratio between the area of the small one and the area of the big one? Is that going to be the same, that 27.9 or close to it? What do you get when you do that math? 28,510, 28,510 divided by 1,000, 22.7. Dun, 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 dun. 27.9. Which is the same as that 5.28 squared, right? So all of the linear things are going to have the same scale factor, and all of the squared attributes are going to have the same factor. So the area is almost 28 times as big for that large windmill versus a small one that you might have in your house. That is all I have for you today, guys. So I'm going to let you out of class 25 minutes early if you want to go. If you want to stay here and work on that test, that district test that I released that's due on the 29th, you're welcome to do that too. As you have questions on that, please ask me and I will happily answer them. Otherwise, I will see you tomorrow.
So we can submit it.
Don't submit it because we have a second part. Yeah, if you submit it, I'll unsubmit it. Elias, you were quiet today.
Bye, Misty.
Bye, Bryce. Elias, I've been recording this whole thing. So what I'm going to do is I'm going to